Okay, in our last video for this chapter, we're going to look at adding and subtracting mixed numbers. And there are definitely two methods for doing this. There's a method that I kind of prefer, so I tend to teach it, but I'll make sure you understand that the second method exists. Okay, so when it comes to adding and subtracting mixed numbers, for me, I prefer to add or subtract the whole numbers and then add or subtract the fractions and then do some simplifying as needed. So with this situation, like when we were multiplying and dividing mixed numbers, we have to convert them to improper fraction. Here you have the option to leave these as mixed numbers. And for me, even though there are some like weird oddities about this, I think this ends up being easier in some cases. Okay, so we add or subtract the whole numbers, we add or subtract the fractions, and then we do some tweaking and simplifying as needed. Now, the alternate method is to convert these to improper fractions and then do the adding or subtracting. And if you prefer that method, go for it. Okay, so this method can be easier depending on the mixed numbers. The issue with this method is if you get large mixed numbers, like where the whole number is big or the numerators are big, if the denominators are different, by the time you find an LCD and then you find equivalent forms of the fractions, you can get these massive numerators that are kind of hard to simplify. So that's why I tend to do the method where I leave them as mixed numbers. It's up to you though, okay? So for example 5, the directions say find each sum, okay? So for part A, we have 2 and 1/6 plus 4 and 2/5. So what I generally do is I start by writing this out vertically, okay? I like to have a vertical setup. So I have 2 and 1/6 plus 4 and 2/5, okay? Now, before we can add fractions, remember, we have to have an LCD, okay? So when it comes to finding the LCD, we want to list out multiples or use the prime factorization table, whatever you prefer. So if we were to list out multiples, we have 5 and 6 as our denominators. So 5 times 1 is 5, times 2 is 10, 5 times 3 is 15, 5 times 4 is 20, 5 times 5 is 25, and then 5 times 6 is 30. And I'm going to stop here. Now, as far as 6 goes, 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, 6 times 4 is 24, and 6 times 5 is 30. So we can see that we have an LCD of 30. Okay, so let's go ahead and rewrite these fractions as equivalent forms of just the fraction. Leave the whole number alone for now. We're going to look at just the fractions and we're going to find equivalent forms of those using the LCD of 30. So for 1/6, I want to convert it into something out of 30. Okay, so what would I multiply 6 by to get 30? Well, we had to multiply 6 by 5. So I want to multiply top and bottom by 5. Remember, that's really just a weird form of 1. So when we multiply by this weird form of 1, we're not changing the value of 1/6, we're just changing its appearance. And so for the numerator, 1 times 5 is 5. Now for 2/5, I want to do exactly the same thing. I want to rewrite 2/5 as an equivalent form using 30 as the denominator. So what do we multiply 5 by to get 30? Well, we'd have to multiply it by 6. So we multiply top and bottom by 6. Let's see, 2 times 12, 2 times 6 is 12. Okay, so let's just clean this problem up. Let's just sort of clean it up, get rid of some of the side work and see what we're dealing with. So what we really are dealing with is 2 and 5/30ths plus 4 and 12/30ths. And now we can add the fractions and then we can add the whole numbers. So let's see, 5 plus 12 would be 17. So that means 5/30ths plus 12/30ths is 17/30ths. And then 2 plus 4 is 6. And at this point, all you want to do is make sure your fraction is proper, meaning the numerator is less than the denominator, and you want to make sure it is reduced. We're good here. 17 is prime. It's not a factor of 30. So this right here is our final answer. Okay? Now for part B, let's look at part B. So we have just the whole number 12. We have 3 and 6/7, and then we have 2 and 1/5. So let's write that vertically and then let's set the stage so that we can, let me make that straighter, so that we can add the fractions. So we do need an LCD. And because we're dealing with just 5 and 7, this isn't going to be too bad, so I'm going to list out multiples instead of doing the prime factorization table. Although, if you like the prime factorization table, it's going to be really quick for this example. So 5 times 1 is 5, times 2 is 10, times 3 is 15, times 4 is 20, times 5 is 25, times 6 is 30, and finally, 5 times 7 is 35, and I'm going to stop there. Okay? Now, 7 times 1 is 7. 7 times 2 is 14. 7 times 3 is 21. Times 4 is 28. And finally, 7 times 5 is 35. So you can see pretty quickly we were able to get an LCD. So our LCD is 35. Now, when it comes to adding, if you have a whole number, you don't have to worry about any kind of fraction. Okay, so we can just keep the 12 as it is. We don't have to have it as a mixed number or anything like that. But the 6/7 and the 1/5, we want to convert those into equivalent forms using 35 as the denominator. So let's get ready. So if I want to convert 6/7 into something out of 35, I have to figure out what would I multiply 7 by to get 35. Well, I would have to multiply it by 5. So we're going to multiply top and bottom by 5. And 6 times 5 is 30. Now let's do the same thing for 1/5. So we want to convert 1/5 to an equivalent form with 35 as the denominator. Okay, so what would we multiply 5 by to get 35? Well, we would have to multiply it by 7. So we want to multiply top and bottom by 7. 1 times 7 is 7. Okay, so let's just clean this up. So now what I'm dealing with is 12 plus 3 and 30/35 plus 2 and 7/35. Well, now I have common denominators, so I can go ahead and add. Okay, so 30/35 plus 7/35 is 37/35, which hopefully you're like, ooh, that looks weird. It does, but we can fix it. Now, 12 plus 3 is 15. 15 plus 2 is 17. So at the moment, we have 17 and 37/35, but you have to go back to when we first introduced this chapter. We said, hey, mixed numbers are a situation where you have a whole number plus a proper fraction. The issue we have here is this is improper. We do not like that. So we have to fix that. So let's think about what this is. If we have 17 and 37/35, that's like 17 plus 37/35. Well, we don't like the fact that that's improper. So let's convert 37/35 to a mixed number. Okay, so this is going to become 17 plus, well, we have to ask ourselves, how many times will 35 go into 37? 35 will go into 37 one whole time, but we have 2 left over. So 37/35 is really 1 and 2/5, and now we can easily add these two. So 17 plus 1 is 18, and then we get that 2/35. So this right here is our final answer. So you can add mixed numbers. And if you add the mixed numbers by just adding the fractions and then the whole numbers, as long as you get a proper fraction like we did over here, you don't have to do any extra work. In part B, when we did our addition, we got an improper fraction in our mixed number. You have to fix that. So you take the improper fraction, convert it to a mixed number, and then just add that to your whole number. Okay? So that is adding mixed numbers. Okay? For example 5, let's look at subtracting. So example 5 says find each difference. Okay? So just like with addition, I'm going to write this vertically. So I have 32 and 7/9 minus 16 and 5/18. Well, we need an LCD. And anytime you see that one denominator will go into the other denominator evenly, you know that the larger denominator is the LCD. So if we start listing out multiples of 9, we see this really quickly. So there's a helicopter going over my house. Sorry, it's noisy. It'll be a relief when I can shut my doors. Okay, so 9 times 1 is 9. 9 times 2 is 18. So right there, we can see we have our LCD. Okay, so 18 happens to be the LCD here. So I don't have to rewrite 5/18. It already has the LCD as the denominator, but I do need to rewrite 7/9. Okay, so I want to convert 7/9 to an equivalent form with 18 as the denominator. So what do we multiply 9 by to get 18? Well, that would just be 2. So if I multiply the bottom, I have to multiply the top, and 7 times 2 is 14. Okay? So let's clean this up. We get 32 and 14/18 minus 16 and 5/18, and now we can subtract, okay? 14/18 minus 5/18, well, let's see, 14 minus 5 is 9, so we get 9/18, and then 32 minus 16, if you need to do a little side work, that's fine, but 32 minus 16 ends up being 16. And all you have to do is make sure you've reduced your final answer. So when I look at 9/18, I notice that 9 and 18 have a 9 in common. So I want to divide both of those by 9. So that tells me my final answer is 16 and 1/2. And that's it. Okay, so that's your final answer. Now, this one, part A, was pretty easy because we didn't have to do what is called borrowing. So if you go back to the very beginning of this course where we were just adding, subtracting, multiplying, and dividing whole numbers, with subtraction, we had situations where we have to borrow. The same thing can happen with mixed numbers, okay? If you do it in this format where you keep the mixed number form and you add or subtract the mixed number or the whole number and the fraction, sometimes you have to borrow, okay? So let's see what that looks like. So for this example, for part B, we have 25 minus 10 and 2/9. Well, the issue here is I need a fraction in the first number. So I need to rewrite 25 as some kind of mixed number form. It's not going to be exactly a mixed number, but it needs to look like a mixed number because I need a fraction to subtract 2/9 from. So what we do is we borrow 1 from the 25. So we take 1 from 25, making 25 a 24. And then the one that we borrow has to be written in fraction form, and it needs to have the denominator that we're looking into. So we need denominators of 9. So that one that I borrow, I'm going to come over here and I'm going to write it as, whoa. I hate when Microsoft tries to like make my stuff pretty. So I'm going to come over here and write it as 9/9. Now, like if you think about that, 24 plus 9/9. Well, we know that 9 divided by 9 is just equal to 1. So this is really 24 plus 1, which is really 25. So we've just found a unique way to rewrite 25 where we haven't changed its value, but we've written it in a form that we have a whole number and a fraction. Okay, so let's clean this up a little bit. What we're really dealing with is 24 and 9/9 minus 10 and 2/9. I now have a setup because of borrowing that allows me to subtract my fractions and subtract my whole numbers. So 9/9 minus 2/9, that's just 7/9, which is proper. It's simplified, looks beautiful. And then 24 minus 10 is 14. So that is subtracting mixed numbers where you do have to borrow, okay? So there you have it. That's an easy example of borrowing. Maybe, I don't know, we've got a word problem coming up. Maybe it has a more difficult example. Let's see. So let's go ahead and look at example 6. So example 6 says solve and simplify, include correct units with the answer. So we have a word problem here. And we are told that Joe and Stephanie, I know I was reading a Stephanie Plum book when I wrote this problem. So Joe and Stephanie purchased 6¼ gallons of paint to paint the interior of their house. They have already used 4 2/3 gallons. How much do they have left? So this is definitely a subtraction problem. So what we're dealing with is 6¼ gallons of paint minus 4 2/3 gallons that have already been used. So how much do they have left? So let's set this up vertically. So we get 6 1/4 minus 4 2/3. Hopefully you're getting really good at the LCD part, but if not, let's do a little side work. We definitely need an LCD, okay? So in this case, it'll be really quick to just list out multiples. So let's list out multiples of 3 and 4 until we find one in common. So 3 times 1 is 3, times 2 is 6, times 3 is 9, times 4 is 12. So I'm liking 12. Let's see if that works for 4. 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. So there you have it. We have an LCD here of 12. So let's rewrite both of these fractions using the denominator of 12. All right, so let's see, when we're looking at 1/4, what would we multiply 4 by to get 12? Well, we'd have to multiply by 3. So I'm going to multiply top and bottom by 3, which gives me 3/12. Okay? Now for 2/3, we have to convert that to an equivalent form using 12 as the denominator. So what would I multiply 3 by to get 12? Well, that would be 4. So I want to multiply top and bottom by 4. So what we have now is 8/12. So let's just clean this problem up a bit. So what we're really dealing with is 6 3/12 minus 4 8/12. And hopefully you're like, oh, what do we do? What do we do? This is a little messy. We have to fix this. Okay. So just like in the previous example, we had to do what's called borrowing. Okay. So we want to take 1 away from the 6. So we're going to turn 6 into 5. And then that 1 that we borrowed, we're going to add right here to 3/12, and we're going to write it in fraction form with 12 as the denominator. So how could we write 1 as a fraction with a denominator of 12? Well, we would just write it as 12/12. And if you think about that, 5 plus 12/12 is really 5 plus 1, or 6. So we haven't changed that 6. We've just rewritten it in a way that kind of works for us. Okay? So let's clean this up. So now instead of 6, we have 5. And instead of 3/12, we really have 3/12 plus 12/12, which makes this 15/12. And yes, this is improper, but it's only going to be improper for a second. So it's okay. It's kind of just like a trick we use to make this work for us. From 5 and 15/12, we want to subtract 4 and 8/12. Okay, so now 15/12 minus 8/12, that is some subtraction that we can do. So I can take 8/12 from 15/12. So I would just take 15 minus 8, which is 7. So that gives me 7/12. And then 5 minus 4 is 1. So we would come over here and say Joe and Stephanie have 1 7/12 gallons of paint left. So it can be a little weird when you subtract mixed numbers and you leave them in mixed number format, because sometimes you have to borrow. If you prefer, you could start by just converting both of these numbers to improper fractions and subtracting there. The one thing I will tell you is, because we're starting with a word problem involving mixed numbers, your final answer does need to be converted back to a mixed number if you choose that method. Okay, so there you have it. That's operations on mixed numbers. Make sure you understand the difference with multiplication and division. With multiplication and division, you have to convert them to improper fractions. You don't have a choice. Compare that to addition and subtraction, where you have the option. You can either leave them in mixed number form, or you can convert them to improper fractions. Either way, you'll get the same answer. Just use the one that you think is most like the easiest and most successful for you.